Well, welcome back to our Equations of a Circle review. We've got a lot to dig into today, so we'll go ahead and get started here. Hopefully you recognize what a circle is. It has a center, which they're calling AB in this picture, and the distance from the center to this outer edge is your radius. If I went across the whole picture of my circle, that would be the diameter. So let's get started. Alright, so let's go ahead and start with a simple circle equation here, and you'll notice that that equation is x squared plus y squared equals r squared. Now in this particular case, we would say that our center is 0, 0, and our radius, of course, is just r. Now here's the deal, just take special note that every term is squared, and that's the whole key. Every term is squared. So in example 1 here, it says this is a circle with a center of 0, 0, and again that's because it's just x squared plus y squared. And here's the deal, guys, just write down r squared equals 16. Now we can easily get the radius by taking the square root of both sides. Now I know that you get positive and negative 4, but since we're talking about a radius, we only want that positive value, so my radius is 4. Now when we go ahead and plot that, you're just going to start with your center of 0, 0, and basically you're going to count 4 in your north, south, east, and west. So I would go 4 north, 4 south, 4 east, 4 west, and then I'm just going to carefully draw that circle in. Alright, now most of our circles aren't going to be centered at the origin. So what that formula is called is your center radius form. And it's very obvious by name because it's going to give you a center and it's going to give you a radius. So here's the formula I have memorized. It is not on the formula sheet. And you did this in geometry. It's x minus h squared plus y minus k squared equals r squared. So again, things to take note of. Everybody is squared. You've got a plus sign in the middle, and you've got your minus signs in the parentheses there. So let's take example 2. Basically, I just want you to write the circle who has a center 2, negative 5 and a radius of 3. So your center is your HK. So in this case, my H is 2, and my K is negative 5. And of course, my radius, they say, is 3. So as I just plug it in the formula, it's x minus h squared plus y minus k squared, so that's going to turn that to a positive 5 squared, equals my radius squared. Remember, everybody's squared, so this time I'll just set it equal to 9. Now, let's go ahead and graph that. So again, I would start with your center, which is 2, negative 5, and then just kind of go your north, south, east, and west, and draw in your circle of 3, radius of 3. So again, I start with my center, north, south, east, and west, I go 3, and then we'll just smoothly connect it. Alright, well, we've done the easy ones. Now we have something called the general form of a circle. And it should be a dead giveaway that it's a circle because, again, you have 2 squared terms. So something special about that, when we talk about functions and we see 2 squared terms, I just want to be clear that this is not a function. When I see that y squared, that's implying that I have that circle. So this is not a function. But anyways, this is the general form, and our goal is to put it in center radius form, which again, that means you can see the center, x minus h squared plus y minus k squared equals r squared. That is my center and radius form. So how do we do that? Well, this should be a review, and I just want to remind you, the way to do this is to complete the square. So I'll walk you through step by step on the first one, and then I'll give you one to try on your own. So watch how I just reorder them. I'm going to put the x terms together, so I'm going to go x squared, then minus 4x, and then I have a positive y squared and a minus 6y plus 8 equals 0. So of course I'm going to take some time, and you should be doing the same thing. You can't do that without. We're going to reorganize them, x's together, y's together, constant on the end. Alright, now just like normal completing the square, I need to make sure that this number here is a 1. If it's not, I would divide every term. So it is, and I'm in good shape. So I'm going to complete the square for the x's. So I'm going to take that b term, negative 4, divide it by 2, and square it. So we just reviewed this last week. So negative 4 divided by 2 is negative 2 squared, which is 4. And I'm going to do the same thing for my y's. Okay, negative 6 divided by 2 squared, so that's negative 3 squared is 9. So watch how I complete the square. I'm going to say it's x squared minus 4x, and I'm going to put plus a number. And I've got plus my y squared minus 6y plus a number. And of course I have to move that negative 8 over, and then I have to add those numbers to this side as well. Alright, so I'm trying to make it very, very obvious. I'm going to add those numbers to everybody. Now, you'll remember when we complete the square, it's always the number that you got here. So I'm going to say plus 4. And here I'm adding 9, and I'm adding 9 to this side. Alright, so as I go through, I'm just going to rewrite this as 2 terms squared. And this is really the quantity x minus 2 times x minus 2, so that's your x minus 2 squared. Plus, this was really y minus 3 and y minus 3. Remember, it's the number you squared. So I can say that's y minus 3 squared equals 8 plus 4 is 12 plus 9 gets me a 21. Alright, so now I'm going to do one more thing and just state my center and radius. Alright, so my center was HK, so in this case my center is going to be positive 2, positive 3. Remember, it's the opposite of those two numbers. And who is this equal to? Well, remember, it's this term squared plus this term squared equals radius squared. So I just want to be clear, your radius squared is 21, therefore your radius is the square root of 21. And we can't simplify that, so we're good to go there with a radius and a center. Alright, so I'll lead you off in the first step, and then we'll pause it and try it on our own. But here's a great example where that leading coefficient has to be a 1. So my first move, before I, organize anybody, is to divide every term by 2. So I'm going to say this is really x squared plus y squared plus 3x minus 4y plus 6 equals 0. So again, I did not factor out a 2, I divided every term by 2. Alright, so why don't you pause it and organize your variables, put your x's together, your y's together, and see what you get. So you can see I put my x's here, put my y's here, move my constant over. Now watch, I think it's important that you just slow down and kind of put a box, and add those 2 boxes to this side. Alright. So again, I have to add a term here, and I'm going to add both of those over here. So now let's take a few seconds and complete the square. I'm taking 3, dividing it by 2, and squaring it. So that's going to get me 9 over 4. I'm taking negative 4, dividing it by 2, and squaring it. That's going to get me negative 2 squared is 4. Alright, so I'm going to add 9/4, and I'm going to add 4, and I'm going to do the same thing on this side. 9/4 and 4. Alright, now this one's just a little uglier because you have to multiply to 9/4, but remember, it's always the term you squared. So this is really x, and that's a positive 3/2 squared, plus the number I squared here, negative 4 divided by 2 is negative 2, so this is going to be y minus 2 squared, equals, let's see, negative 6 plus 4 is negative 2, and you can grab your calculator if you need to. I'll do a little mental math here. Negative 2 plus 9/4, which is really negative 4/4, so I'm going to get a positive 5/4. So lastly, we just want to state what our center and radius are. So again, I'm going to say center is negative 3/2, comma 2. And I'm just going to take note that this is actually radius squared. Therefore, my radius is the square root of 5/4. And I can clean that up a bit. I don't know the square root of 5, but I know that the square root of 4 is 2. So that comes out. So if at any point I talk too fast, this is review. Pause it, rewind it, and make sure you can do this. Alright, next equation. Write the equation of a circle whose diameter has the endpoints of 4, -1 and -6, 7. So I can't do this without a sketch. I got to think about what I have. We'll quickly sketch it out. 1, 2, 3, 4, negative 1. And negative 6, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And what do those represent? That says that's the endpoint of the diameter. Well, the diameter goes across the whole circle. So you can kind of picture that the circle is going to look something like this. Okay, that diameter should be going across the whole circle. So now I just say to myself, well, what do I need to write this equation of a circle? I need a center, and I need a radius. Okay, at the moment, do you know either? All right, I have no idea what those are. I don't know what the center is. I could kind of guess approximately, but I don't know. And I have to find this distance, the radius here. All right, so we're going to have to slow down. Let's talk about getting the center first. How would you describe the center? The center is the what of that line. Hopefully you're saying midpoint. All right, so let's review our midpoint formula. This is not given on the exam. Okay, the midpoint is the average of the x's. So x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So basically we'll take our x values, add them together and divide by 2. So 4 plus negative 6 divided by 2. And then we'll take our y values, negative 1, plus 7 divided by 2. And this will tell us our center. And hopefully, like you can kind of guesstimate, it looks like it should be at negative 1 or negative 2. And let's see if we can verify that. If I 4 and negative 6 make negative 2 divided by 2 gets me a negative 1. And negative 1 plus 7 is 6 divided by 2 is 3. And we kind of guesstimated that. So negative 1, 3, and again, not drawn to scale here, should be my center. So I'm going to box that in. That is the center of my circle. Now, what else am I missing? I need the center, which we said we just found is negative 1, 3, and I need the radius. Well, I can't count because it's a diagonal line. So I've got to use that very fun distance formula. Now, who do you need the distance of? Well, you've got two options. You could find the distance of this whole line, but that would be the diameter, so you'd have to cut it in half. But now that you know the center, you could just use the center in one of these points, and that's what I'm going to do. So let me remind you that the distance formula is the big square root, change in x, x1 minus x2 squared, plus y2 minus y1 squared. I should put these in the same order. I'm going to say y1 minus y2. I think I said that, but I didn't write it. All right, and now what are the 2 points I'm going to use? So remember, I want this distance that I put in orange, and that's between this point, which is negative 1, 3, and this point, which is 4, negative 1. So let's go ahead and find the distance there. So I've got square root, change in x's, I'm going to say 4 minus negative 1 squared, plus negative 1 minus 3 squared. So 4 minus negative 1 is 5 squared, that's 25. Negative 3 minus 1 is negative 4 squared, that's a 16. So that's going to get me the square root of 41. Now we're ready to put it all together. We know that our center is negative 1, 3, and we know that our radius is radical 41. So let's throw it in the equation. It's x minus h, so minus negative 1 squared, which is going to turn to a plus y minus 3 squared equals, and remember, what does the formula say? It says it's radius squared. So if I take my radius and square it, I'm going to just get 41. And there is the center of that circle. And the equation, I guess I should say. We have the equation of that circle. All right, write the equation for the circle shown below if it is shifted 3 units to the right and 4 units up. Well, the first thing I would do is just identify what is the equation of this circle. Well, it's centered at the origin, which is always nice, so that's just my x squared plus y squared equals radius squared. So I've got x squared plus y squared equals, can you count the radius? I think so. It's just a nice, horizontal line there. I would say that's a radius of 5. So radius equals 5, so that's going to be 5 squared, which is 25. So this is my current equation of the circle. Now it says take that circle and shift it 3 units to the right. So I'm going to go right 3 and 4 up and up 4. All right, so if I go to the right 3, all right, and I'm just going to draw it in. I'm going to move the circle right 3, so I'm going to count over 3, and I'm going to go up 4. So I'm going to say my new center is going to be right here, and that coordinate is 3, 4. So if my center is now 3, 4, what is my equation going to be? So I'm going to say x minus our h squared plus y minus k squared, which is 4 in this case, equals, is your radius going to change? If you just take this circle and pick it up and move it, you should have the same radius. So it's still going to be equal to 25. And there you go. Center of our new circle when it's shifted 3 to the right and up 4. All right, we'll change the wording again. Write the general equation of a circle that is tangent to the x-axis. Let's talk about that keyword tangent. That was a big geometry word, and if you're tangent, you only touch this circle, or whatever you're tangent to the x-axis here, you touch the x-axis once. So let me give you a quick example. If I have a circle and I draw a tangent line, it's just going to skim it and touch it once. Now I could draw that tangent line wherever I want. It could go this way and touch once. It could go this way and touch once. But the idea is that when you're tangent, you touch it once. So I think it's more important if you just quickly sketch this out, and it'll make our math a heck of a lot easier. So it says my center is 4, negative 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. All right, and I'm going to label that 4, negative 6. And it says your circle is tangent to the x-axis. You are going to touch the x-axis once. Can you picture what that looks like? All right, can it look like this? Would that touch my x-axis only once? I hope not. I can see it would touch here and here. And it couldn't be this small because that doesn't touch the x-axis at all. It's got to touch just once. So basically, I'm going to draw in my radius. I'm going to go up to that x-axis, and I'm going to say that's a radius of 6. I count 6 up. And basically, I'm just going to go 6 in every direction. And hopefully, it's going to look like this. And it's only going to touch once. And now it says, what's the equation of that circle? Well, I think it's pretty nice. I'm going to say that's x minus 4 squared. Okay, x minus h squared plus y minus k squared, those two negatives are going to make a positive squared, equals, remember it's radius squared. And we just said, how big was our radius? We were 6 away, so equals 36. All right, well, it's that time of the night. We've got a quiz question for you, and we will be grading this as your Monday quiz, so let's make sure it's perfect. You might have to go back and look at those notes. I'm going to warn you right now, take note that you can't just start completing the square if you have 3's up front. Remember, you got to divide every term by 3. So good luck, and we'll see you tomorrow. Have a great night.